This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 9 problems from the September 2025 Digital SAT Math exam. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I begin going through this second worksheet of September 2025 Digital SAT Math problems, I want to mention a couple things that I talk about at the start of all these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, if you have any questions or comments or alternate solution methods, please leave them in the comment section below. Third, there'll be a link to the PDF file which has all these problems in it, both in the description of the video and also in the pinned comment of the video. And lastly, so I've gathered these self-reported questions from mainly from Reddit, but also from a couple other sources. So I've tried to make them as realistic as possible, but it still might be that if you had one of these questions on your official exam, it's worded slightly differently or asking for something slightly different than what than the problem you had. Okay, so just keep that in mind. I've tried to recreate them as best as possible to make them workable problems. And related to that, you might have had the question as a multiple choice question, but I have it as a free response. So there could be other methods you could use to solve the problem if a question is multiple choice versus free response. All right, so with all that being said, oh, and also one thing, I mentioned this in the first video as well, for this month and probably for months coming up, because there's so many tests in such a short time period, I'm only going to focus on like kind of new or unique questions that generally haven't really been covered before. I'm not going to do a lot of the repeat questions that have been out there multiple times previously. So if you're interested in like the circle, the triangle in a circle question where you're finding the ratio of the two segments to make up the diameter, you can go check out one of my older videos. I'll put the thumbnail up on the screen to show you how to solve that problem. All right, so let's go ahead and get started then with question number 1. So there are multiple ways you can solve this one. You can do it in Desmos, and I'll show you the various ways in Desmos. You can do it by hand, but basically we're looking to set the discriminant greater than or equal to 0, essentially, because we want two real solutions, and we want k to be an integer constant. So we're going to look at b squared minus 4ac. Okay, b is equal to negative 16. A is technically negative 25 plus k. So this is the one thing that's kind of a wrinkle that I don't think we've seen before. Technically, like, you have two a terms here. So really the way you would need to write it, like, you would factor it out like this. You would factor out the x squared, and then you have negative 25 plus k. Or if you just want to make it k minus 25, whatever. Let's just do it that way. You know, a little easier to follow because we typically put variables first, and then the number subtracted second. All right, and then of course for c we have 8. Now technically you want this to be greater than 0, but what I'm going to do is I'm just going to go to Desmos and I'm going to solve it just to avoid doing all the work by hand. I'm going to solve this for being equal to 0, and I'll explain why just in a second. Okay, so it returns k is 33, not 30. K is 33 when the discriminant is equal to 0. What that means is when k is equal to 33, there is one real solution. Okay? Discriminant equals 0 means one real solution. So if we want to find the value for which there are two real solutions, technically we need to check on either side at either 32 or 34. One is going to be two real solutions, one's going to be no real solutions. We just have to determine which one. I think that's easier than solving out the inequality to do this all by hand. But again, you could just solve it out by hand, whatever. I'll do that later, just after this. So now what I would do is I would just go here, and you could either type in for k. You could replace it with 32 or 33, or I'm just going to type here the following. First, I'm going to get rid of this, and then I'm just going to type k equals 34. Okay, did I get a positive discriminant value? the answer is no. K equals 34, the discriminant is less than 0, that means no real solutions. So that's not going to be our answer. Okay, should be 32, so let's go ahead and check that. Notice now I get a positive discriminant value solution, discriminant greater than 0. That means there are 2 real solutions. So therefore, what is the largest value of k? Well, it's just 32. That's our answer. That's what you would report. Now, if you want to do this by hand, right, you would just square this and get 256, and then minus 4k plus 100. Now, let me just actually, sorry, let me do it this way because I think it's going to be easier to understand. Let me multiply these two first to get negative 32, and then we get k minus 25. Okay, greater than 0. Then we get, let's see, 256 minus 32k plus 32 times 25. Don't know that off the top of my head. 800. That's positive, greater than 0. So now if I want to solve this, I get negative 32k. Okay, this and this is 1056. And then I have to so plus 1056 greater than 0. Then I subtract it to the other side, negative 32k greater than negative 1056. Divide by negative 32, divide by negative 32. K is greater than, what do we get? 1056 divided by 32. Technically, they're both negative. Okay. So notice, technically, and I change this here. Sorry, change this here. I get k, the sign flips because I'm dividing by a negative, and then 33 is the number here. So when I solve this out, I get k is less than 33. So then you're thinking, okay, what's the largest value of k? Well, since it has to be an integer, the answer must be 32. All right, so that's another alternate way to do it, but I would just prefer to go straight to Desmos instead of spending all this time writing out the algebra. Now, let's show you a couple quick methods you could use to do this in Desmos. And I'm talking about doing it entirely in Desmos, not just using Desmos for the discriminant calculations. So step 1, type out the entire original expression as f of x. Type out a second function as g of x and just make that 0. This is always going to be 0. If you want to know how to use this method, check out the video for which the thumbnail is being shown on the screen right now. I call it the derivative method. Then we do f of x1, f prime of x1, tilde. Then we get basically we're solving a system of equations for the function itself, for both f of x and g of x, and their derivatives. So when I do this, it gives me a k value of 33. What this is finding, again, is the values are such that there is one real solution. Then you just have to check on the other side of that. So what you would do here then is you would type k equals 34, and you would look at the graph. And you would see, are there 2 real solutions or no real solutions? Okay, clearly there's none, so now I would go back and I would check 32. Okay, now I would see that there are 2 real solutions, therefore this is the correct answer. And again, this is how you could get the entire problem done in Desmos. All right, let's look at the next one. Let me erase some of this work just so we can read the problem nice and clearly. Okay, so question number 2. They give you this function, and it's an exponential function, and it says it's greater than k for all values of x where k is a constant. What's the largest value of k? So what's really going on here is essentially a horizontal asymptote, because if you graph this out, and this is just going to be easier to, I think this is going to be easier to demonstrate visually than like just describing it. It's an exponential function. It goes up, it's increasing to the right or decreasing as you're going to the left. You just zoom out, here's a better picture of it. So as the x value gets smaller and smaller, i.e. as you get increasingly negative, this whole first term right here, the 6 times 2 to the x, just goes to 0. So like this whole thing right here, as the x value gets negative, it then becomes 6 over 2 to the x, but it's positive because you would flip it. And the point is, this whole term essentially turns to 0, drops out, disappears. Therefore, this 1/27th acts as a horizontal asymptote. And so the answer for this, the largest value of k that everything is greater than is technically 1/27th. Now you could also put it in as its decimal equivalent if you wanted to. So you could enter basically 0.037. You could also enter 0.0370. I don't know if that would, I guess entering that last 0 doesn't really matter, but because I guess technically you would, because it doesn't terminate, so I guess you technically would need to fill up the entire thing, even though it's just a 0. But anyways, this is the answer, and the real reason is because like with a standard exponential function with no vertical shift, like if this wasn't here, right, it just approaches 0, whether it's going, whether it's an increasing or even if it was a decreasing. It essentially has a horizontal asymptote at y equals 0. So this just shifts it up to basically 1/27th. So the correct answer for this is 1/27th. All right, let's look next at another problem that's going to be easiest to kind of, I think, visualize from the graph. So I'm not going to bother kind of like doing this by hand or going through the theory. I'm just going to graph it and see what happens on the graph, because again, I think it's much easier to understand what's happening here via the graph. So there's the original function 27x cubed, right? It's a cubic polynomial. Just zoom this, size this down a little bit. Okay, so there it is. Now what we're doing is we are basically replacing x with a negative x. So that's going to cause it to flip, essentially a reflection across the y-axis. And we're adding a value to it. And the key is this value is a positive number. So let's just say c is equal to 2. All right. The x and y intercepts of the new graph, so let's just take away the old one. We only want the new one, are r comma 0 and 0 comma t. So what's true about r and t? Basically what they want to know is, are they both positive, both negative, or is it some combination? All right, so we can just easily see here from the graph, okay, the y-intercept is obviously positive, right? In the original function, it's 0, 0. Now it went up by a positive constant, so now it's going to be greater than 0. So t must be greater than 0 for sure. So I can get rid of this, and I can get rid of this. Now the question is, what is happening with the r value, or the x-intercept? Well, you can see here, basically, if you only did the shift, if you didn't do the reflection, if you only flipped it right, then the x-intercept would be like over here in the negatives, but because of the reflection, that's why it flips over to the positive. So r must be greater than 0. Therefore, the correct answer for this problem is just going to be letter A. Basically, they are both going to be positive. And again, I think it's easiest to just graph out the function in Desmos to visually see, what's happening with both of them. All right, let's move on to the next page. Top of the next page, question number 4. So this is basically just a conditional probability problem. So the question wants to know, what's the probability of selecting a brown pair of pants given that the pants are regular size? Okay, this part right here, this is the conditional part. This means we are only choosing from the 60 regular size, whatever, pairs of pants. That means your denominator will have to be 60. Then, what's the probability that they're brown? Well, there's 15 possible pairs that we could choose out of the 60. So the answer to this is just 15 over 60. Or you should probably, you don't need to, but you could also put it in as 1/4, it's a simplified fraction. Or you could also put it in as 0.25. Or you could also technically enter 0.25. Okay, so all of them would be accepted, and that's just the correct answer for this problem. Next, let's talk about question number 5. This one deals with similar triangles. So you have two triangles, and so I'm just going to sketch, let me just look at my notes here, how I sketch these out. Okay, A, B, and C, P, Q, and R. All right, so we know that B is 56, and we know Q is 56. Okay, so these are the same. And also notice we're proving A, B, C, and PQ are similar, which means we want A to correspond to P, B to Q, C to R, right? We want those vertices to match up. So which of the following is sufficient to prove that these two triangles are similar? So there's three methods. There's AA, angle, angle. There's SAS, side angle, side, and SSS. Each of the A's stands for a pair of congruent angles. Each of the S's stands for one pair of proportional sides. So let's see what we have. Okay, answer choice A. AB equals 10 and PQ equals 20. So far we have one pair of angles and one pair of sides, but that's not enough. So therefore, this answer choice is not sufficient. Now, in B, we have the same information, but we also have AC equals 12 and PR equals 24. So these are both pairs of sides are proportional by the same scale factor of like 2 to 1. You know, the triangle on the right is double the sides of the triangle on the left. But this is not one of the approved methods. This is not SAS because the angle must be included between the pair of proportional sides. And in this example, it is not. This would be like SSA. Therefore, this is not an acceptable method. Okay, now you can probably already recognize that it's not going to be C because, again, we only have one pair of sides here, and that's just not enough. So the correct answer is going to be D. And so basically what you have is, okay, we know this is 34, and we're told this is 90. So you're right now, if you look at the diagram, you're like, well, we still only have one pair of congruent angles. However, you can determine that, 56 plus 34 adds up to 90, which means 180 minus 90 leaves angle A also being 90. Now you technically have two pairs of congruent angles, and you can use angle-angle similarity. Similarly, you could also determine that angle R is 34 because 90 plus 56 is 144, and 180 minus 146 is 34. Therefore, you also could have two pairs of congruent angles, B to Q and C to R. So in either case, the correct answer is D for this problem. All right, let's look at another one now. Problem number 6, bottom of the page. This is the sunlight, or I think some people mentioned daylight type problem. So you have a quadratic function, and you're given basically a couple points on it. So you have 5, 11.52. This is the time. This is the amount of sunlight. Then you also have 3.5. Time in terms of number of months after a specific date, March 1st. 3.5 and then 12.33. They also tell you, and this is the key, that this point right here, this is your vertex. In other words, this is when there was the maximum amount of sunlight. Okay, find the estimated amount of sunlight on March 1st. So all we need to do really for this is find the value of A for this quadratic in vertex form, and then once we have that, just plug in technically 0 for x. Really, we're finding like the y-intercept value, because March 1st would be 0 months after March 1st, and that's just going to correspond to the y-intercept. All right, so with all that being said, we've got y equals a parentheses x minus h squared plus k. I will show you, of course, how to do this in Desmos afterwards, meaning entirely in Desmos, but if you're going to start to set it up by hand, so this is my h and this is my k. So we've got minus 3.5 a, okay, k is the 12.33. My y value is 11.52, and my x value is 5. So now what I would do is I would go to Desmos, and I would just type this in as regression. Again, I wouldn't bother solving this by hand or doing the actual calculations out. All right, so when I do that, notice I get negative 0.36. Or if you want to turn it into a fraction, it is negative 9 over 25. Okay, so negative 0.36 or negative 9 over 25. So now the equation looks like this, and you're just going to plug in the value of 0 for x, and that's going to be our answer. So I'm going to go back slide this over, go back to Desmos, and I'm just going to do a times 0 minus 3.5 squared plus 12.33. It comes out to 7.92. So the correct answer to this problem is 7.92 hours. Of course, you're only going to type the number in, not the unit in any way. But that is your answer. That's how you can solve this problem. Now, let's show you how you could just do the entire thing in Desmos. Okay, so what I would do is, first I would add a table, and in my table I'm going to put in the 5, 11.52 point. You don't need the vertex point in the table. I mean, you can add it if you want, but it's not going to change anything. Then I'm going to do a regression for a quadratic function in vertex form. And now here is where you do have to enter the values for h and k, meaning here's where I would replace the h with 3.5 and I would replace the k with 12.33. The advantage to doing this is now, for March 1st, since you want the y-intercept, you can just easily go right here and click, and you can just see, oh, it's 7.92, and that's it, and you're done. Okay? So this is how you could do the entire problem in Desmos, probably quicker than writing it all out, doing all the calculations by hand. All right, let's look at the top of the last page now. Question number 7. Here you have a square with a diagonal length of 20. It wants to know what's the area of the square. So to find the side lengths of the square, you have two approaches. If you know that this is diagonal divides a square into two 45, 45, 90 right triangles, you could just use the fact that the leg is equal to the hypotenuse divided by root 2. And if you do it in Desmos, you actually don't even need to simplify this. It's going to be root 2 over root 2, and then it's 20 root 2 over 2, and it just really the sides become 10 root 2. But again, in Desmos, you could just keep it as 20 divided by root 2, and then notice for the area of a square, you just square that. Okay? So let me just jump back over to Desmos. So a couple things. Again, you could just do 20 divided by square root of 2. That's the length of one side, and then we're just going to square that for its area. And that gives us the answer of 200 centimeters squared, but again, we don't care about the units. Now, if you didn't know that, if you don't remember the special right triangle formulas, then what I would do is I would do the following. I would say, okay, x1 squared, plus, or actually, I'm going to do it this way. Sorry, I just realized. I'm going to do a squared plus a squared is equal to 20 squared. Because in a square, like both legs are the same. We don't need to do a squared plus b squared because these are the same length because it's a square. So now you get the value of a. Don't worry that it's a decimal. That's irrelevant. And now you just do, okay, a squared. And notice it comes out to exactly 200, just like we did before. So that's how you could get the correct answer using an alternate approach for that problem. All right, let's look at number 8 next. So this one is similar to a question that was on the first problem set, except now it's asking for which of these has the highest median. Okay, so if you notice, for A and C and B, or A, B, and C, all of them have frequencies which are basically symmetric, right? It's like the outmost values have the same. Then the next innermost have the same, then this one has the highest. Same, highest. Same, highest. Because of that symmetry, that means the median value will be the middle value for each of these. I mean, you could add up how many total items there are and you could count it out, but it's always going to work out that way. Because if you did it on a dot plot, right, where it's like 2, 4, 6, 4, 2, for example, for A, the median value, if you start counting from either end, by the way, this should have 2, not 3, like 2 cancel out with 2, and then 1, 2, 3, 4 cancels out with 4, and then you're left with just all these in the middle. So the point is, median for A, B, and C are all going to be 8. Therefore, the correct answer for this one is going to be letter D. And the reason is because notice, this is not symmetric, but this is actually kind of shifted to where the highest value is to the right. See, where it's up, there's more values up here at 9 and 10 than there are, compared to like 6 and 7. Like in every other one, the 6 and 7 frequency matches the 9 and 10 frequency, but not in this one. So, just to confirm that, just to show you, we have, let's see, 6 plus 6 is 12, 12 plus 8, 20. There are 30 total values here, right? So 30 divided by 2 is 15. That means the median value is going to be the average of the 15th and 16th values if you wrote them all out. So you would add those two together and then divide by 2. So let's count up down the chart. 2 plus 4 is 6. 6 plus 6 is 12. We didn't get the 15 or 16 yet. Okay, now 12 plus 8 is 20. That means the 15th and 16th values, 15th, 16th values are both 9. So the average of 9 plus 9 divided by 2, well, that's just 9. So the median for this one will be 9, whereas all the others have a median of 8. All right, last question now, number 9, at the bottom of the page. So here you have an exponential function, and this is just talking about, basically it's like exponential decrease or decline. You know, essentially something is decreasing. And here, notice x is a number of months, but it's talking about the surface area decreasing by p% per year. So that's really, I guess, essentially meant to like trick you, because this question is not as difficult as it seems or as it appears. So if you notice here, okay, if you plug in 12, because 12 months represents 1 year, right? Then 12 over 12 becomes 1. And 0.24 to the 1 is just 0.24. And then you're multiplying 400 by 0.24, right? Multiplying by 0.24 is equal to a 76% decrease. The question is, why is that? Like, or how do you know that? And the reason is because, essentially, this 0.24, really, you could write this as 1 minus 0.76. Because exponential functions, the general form of them, right, you have like the a, the initial amount out front, and then it's like 1 plus or minus r. And r is either your growth rate or your decline or decrease rate. So in this one, the decrease rate is 76%, which corresponds to multiplying by 1 minus that number, which is 0.24. So the value you would enter in for p is 76. Now, let me show you in Desmos mathematically how that works out, just to confirm it. So I'm going to type the function in, x over 12. Okay, I'm going to see, all right, let's say from after 2 years to 1 year, or from 1 year to 2 years, okay? That total time difference is 1 year. I'm going from like after year 1 to after year 2, how much it's decreased by. So I'm going to use percent change, the formula for that, which is like new minus old divided by old. However, the problem is, so you might think, oh, f of 2 minus f of 1, you know, divided by f of 1, okay, times 100%. Okay, well, it's not coming out to 76%. What's the problem, or what's the issue? The issue is we have to remember that t is the number of, or x, sorry, x, not t. X is the number of months, not years. So for 2 years, I don't plug in 2, I plug in 24, because 2 years is 24 months. And for 1 year, I don't plug in 1, I plug in 12. And so I do the same on the bottom. Now, notice what it's showing me. The change from, say, year 1 to year 2 is a 76% decrease. The negative is what means decrease, and the 76 is the answer to the problem. And you could also do it from like year 0, or at the start, to year 1. In other words, you could do f of 12 just minus f of 0, and then divide by f of 0, and notice we get the same answer, okay? So that's how you could just check this or confirm this in Desmos. All right, so I hope you enjoyed this second September 2025 Digital SAT Math official exam problem set. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please do leave them in the comment section below. Also, if you haven't done so already, check out video and worksheet number 1, which goes through 9 other additional problems from the September 2025 test. And lastly, if you're looking to improve your Desmos skills, please check out my Ultimate Desmos Guide to Digital SAT Math. It is over 5.5 hours of tips and tricks and instruction and practice problems to help you master the digital SAT math section.